Yeah. Hi all. Can you all hear me loud and clear? Please use your chat windows to communicate. Wonderful. Yeah, I see all of you can hear me loud and clear. So first of all, thank you and welcome to the second episode here at Southeast Asia Conference. Uh, Before we begin today's session, I'll just give a quick brief. So we have organized the Southeast Asia Conference for all of you to bring in and expose all of you to speakers across the entire Asian region, okay, the Southeast Asian region, one of the fastest growing market. So yesterday we had gotten Sheetal Kumar. Sheetal Kumar, as all of you kind of are aware, that he worked at Smartfree Telecom Indonesia. He's working at Smartfree Telecom Indonesia as senior data scientist. Okay, and plus he had written quite a few books on leadership, data science. Today, we have another interesting speaker who works in Kuala Lumpur, Malaysia. So we have Sathish Punati. And Sathish, if you may enable your cameras, the audience would like to see you. And you can say a quick hi to them before we hand it over.
Hi. Hello, everybody.
Hi, Sathish. So,
welcome to the session. Yes.
Yeah. So, Sathish, thank you for sparing your valuable time for us, for the community, especially that we plan to kind of learn a lot from you over the next 1 hour. And in that, what we would do is first I'll give you a quick intro about you to the audience, and then I'll hand it over to you. After your talk, I'll request you for another 10-15 minutes of Q&A, wherein we'll try to capture some of the questions that our audiences have, and we'll get your understanding on these topics. Right?
Definitely.
Okay,
yes.
So I'll just give a quick introduction of Sathish, and then I'll hand it over to Sathish. I'll not take any further time of his. So Sathish is a senior data scientist with Hong Kong Leon Bank in Kuala Lumpur, Malaysia. So he's worked with multiple clientele all over the world, and I think Sathish, you have been to many countries, right? So right from US, Africa, Indonesia, Malaysia.
Yes.
So you have a flair of traveling, I guess. So
yes.
See that you have been working in so many different places, and you have also worked in different domains, right? Automotive, manufacturing, and banking. So quite a few exposures.
Yes. Healthcare also. Yes.
Healthcare also. Okay, wonderful.
Yes.
So that's like another added feather in the cap. Now, as a lot of you already understand that banking is one space that has seen a lot of disruptions with the introduction of AI and data science. Okay, so Sathish himself is a person who's working with all of these pretty frequently in the banking sector, and possibly this is where Sathish, we would really love to learn from you as to what exactly work do you do behind the scenes. How do you build scalable solutions? How do you think about pipelining your solutions for automation purposes and whatnot? There are many features around it. So in your talk, Sathish, can you give the audience a quick brief and tell them what we plan to cover today? And then we'll listen to you for the next, say, 45 minutes, as long as your talk is. And then we'll open up for some Q&A. Okay?
Sure.
Okay. Thank you, Sathish. I'll then I'll pause my mic. I'll mute my mic and I'll pause my video, and I'll hand over the session to you.
Okay. Let me share my screen presentation and show. Yeah.
Sure.
Can you guys see my screen?
Not yet shared, Sathish. Check if it is shared.
So can you see this one? I think. Wait a second. Small glitch here. Oh. Sorry, guys, 1 second.
I'll be able to see the screen, but yeah, the presentation you might want to.
Yes.
Yes.
Okay. Can you see now?
Yeah.
Okay. Sorry. Let me. Okay. So small introduction from my side, like you said. So currently, I'm working as a senior data scientist in Hong Leong Bank, Bahrain, Malaysia. In marketing, communication, and analytics department. So generally, what we do here in marketing and communication department. So we target a group of customers for these special products for the bank. Okay. And many other products which I'll tell you in further presentation. Coming to my career, I started as a data analyst in South India on Infogem Web Solutions. The client is Indonesian hospital giant Siloam Hospitals. There we work the data on the medicines used by the hospital. Okay, so we take the SKUs of the medicine and we do the inventory management. Okay, so what medicine should be readily available for the hospital for the patients. So instead of buying the unused medicine and keeping hold them in their inventory, so we worked that and with good results, we could able to deliver the Siloam hospitals like what are the fast moving medicines and all. Okay. After that, I started working with Caterpillar USA. It's a automotive giant, Caterpillar is into many verticals like many engine manufacturing and vehicle manufacturing. There I worked on two projects. One on engine image recognition. Okay, like whenever a particular machine is brought to service center, so at the starting, a capture image is captured using the CC like closed circuit camera, and that is processed, and a slip is given to the driver to go to the particular bay of that particular engine and machine. Okay, that is image recognition using the CNNs and all. The other project which I did in Caterpillar is shipboard engines maintenance. Okay, large ships will be when they should be brought to the shore to get the engine service. Okay, not to wait until it gets some default, so that the cost of the service will be more, right? So we gather the data from the IoT that is present inside the engine. Okay, from the data we analyze, we use machine learning algorithms and all to predict what is the right time to bring the engine to the shore to get it serviced. Later, I started working in the manufacturing sector, like pulp and paper manufacturing industry, RG Group, with the Indonesia client. Okay, so they are the world's largest pulp and paper manufacturing industry. So there I used we developed one algorithm to predict a kappa number. So that helps in how much quantity of the bleach used to polish the paper. Okay, so it sounds a little bit easy thing, but it costs hundreds of thousands of dollars to buy the bleach to clean the paper. So we predicted a good number of the kappa, so that to reduce the amount of the bleach to be used. Okay, that is also that saved thousands of dollars for the company there. And next, I worked with East African clients, Zimbabwe and Zambia, on fleet management, okay, theft prevention in fleet management, and for a dairy insurance company also. For there, we have used image recognition techniques of the animals to find whether the animal that is insured correct or not when they brought the dead animal for the insurance claim. Okay, so SIFT algorithms and machine learning algorithms we have used there to predict with a good accuracy what type of animal and all. And now currently, like I said, into banking, Hong Leong Bank. So here we are using multiple techniques for customer segmentation and target marketing and all. So this is brief introduction of mine, and the agenda which I'm going to cover today. The simple things like brief concepts of data science and applications of data science concepts in banking. What are the impact of these analyses for the industry, and what are the technologies that we have used in getting these analyses done, and in the end, small Q&A session. Okay. The first thing, what is generally what is a broad term of data science? Okay. It is a multidisciplinary blend, I mean, mix of data inference, algorithm development, and technology. I mean, these things are mixed up and used to solve analytically complex problems, right? So whenever there is a big business problem or a complex problem comes to us, so we should generally use this particular set of methods to solve and provide a business solution to the client. Okay, I mean, here the technology term I've used just for like what Python or what language and what computer science infrastructure we are using. Okay, and the main center of the whole problem we are dealing with is data. Okay, so generally nowadays we are getting troves of raw information. I mean, the data, we are getting so much data and getting stored in our data enterprises and warehouses. Okay, so we have to mine a little bit deep into the data, and we have to build and inferences from mining the data, something like that. So generally, the ultimate aim of the data science is uh, to generate business value. Okay, I mean, we should be able to show some solution, right, to the business or the problem. What is the problem? What we analyzed it, how we solved it, something like this. Okay, so this is the broad concept of data science. And so this is the typical Venn diagram which I used to show what are the different wings that are in the data science. Okay, what is a mixture of which technologies and all. Okay, generally if you take three big circles which are having the computer science or IT or programming something, and the other circle is maths and statistics, and the other one is domain or business knowledge on the particular subject. Okay, so it is a mixture. I mean, machine learning, if you want to see on machine learning, you should be good with something like programming languages, data science, data structures and all, and you should be good at maths and what are the stats and probability that are involved set inside that. Okay, if you blend of these two, we can make it as a machine learning, and a blend of mathematics and statistics and business knowledge. If you have these both, you can do a traditional research, not writing program or teach a machine to learn or something like that. Just with this knowledge, you can do traditional research to find a business value, something like that. And if we have these two, we can develop a small software to run the data and get some insights. Okay, so that is why here we put data science to mix everything. Okay, I mean, the computer science, the math, statistics, and domain knowledge. End of the day, if you don't have a bit domain knowledge or the subject knowledge on the problem which you are working, you don't be able to deliver a perfect solution for the business problem. Okay, so this is a typical mixture of everything. Okay, and generally what are the things that might involve in a data science project or problem. Okay, so these are the things like visualization. I mean, the data, we should be visualize it, what are the, how the distribution is there, and how the data is missing or something like that. We can get visualizations. And data mining, so missing data finding and all. What is the database and how to process the database using SQL or something like that. And computing, using Python or R, how to pull the data and to work on something like that. And machine learning. And finally, pattern recognition. Okay, what type of pattern is present in the data, something like that. So these are different verticals that are all involved in current data science problem. Okay, it is not confined to only visualization. If you visualize a problem, that is not the solution, right? So you should mine the data, and you should find to recognize the pattern involved there, something like that. Okay, and a typical project life cycle of a data science project revolving around these cycles. Okay, first we should be understanding the business problem. I mean, whenever we got one problem, we should be clearly understand that one. Then what is the data required to solve this problem? So we should write it down, and we need to find what are the ways to collect the data. Okay, and data preparation. So we directly might not find the features that required to solve the problem. Okay, so we have to do some data preparation. Okay, combining two features to get one new feature so that it might help us in solving the problem, something like that. And exploratory data analysis. So if we do some data analysis, a small box graph or some distribution charts or pie chart, something like that, you will get a basic idea how data is there. Okay, is there any missing data or any outliers in the data, something like that. After everything is ready with the data, if you got, after getting some idea what is there in the data, next should be going to the modeling. Okay, modeling can be done using, with Excel also. You can develop a model with Python, with R, or any other computer programming where we can do the modeling. Okay, so there are many algorithms in machine learning also involved in modeling based on the problem. Okay, based on the problem like regression or classification, something like that. Then we have to evaluate our model. Okay, so we divide the data into some training data and some test data. Okay, we train the algorithm on the trained data. Okay, and we use the model to predict the results. Okay, and we have to compare the predicted results with already the results which we have having. Okay, so that will help us in evaluating the model which was developed by us. Okay, if everything is good, we will deploy the model into to the client. Otherwise, we need to do some more changes or error reduction techniques here in the model evaluation, and after that we should deploy it to the client. Okay, so this is a typical life cycle of a data science project. Okay, so generally just explaining a brief terminology on the concepts like what is artificial intelligence and all. uh, Anything not thought and done by human, we call it as artificial, right? That is simple as this one, artificial intelligence. Okay, so many fields are there where we use artificial intelligence nowadays. So these are the three simple diagrams I put it. Okay, so this is one image recognition technique. Okay, we use CNN and OpenCV, other libraries in Python or other techniques to find what this particular image shows to us. Okay, we train these algorithms on a lot of data, sample pictures, and these. If you give a new picture to the algorithm, it should be able to predict something like this. Okay, this is the image of a tiger, or this is of a monkey, something like that. This comes under image recognition, and the other thing is speech recognition. Okay, so speech recognition is like audio recognition. So it should listen to the conversations with the customer care or something like that. After hearing the conversation, it should be come to one decision what the customer is saying, something like that. Okay, from audio to idea generation, that is a speech recognition. And this is like for auto driving cars, Tesla and all. So there is a lidar technology, one camera will be adapted here, so it will take the images of surroundings and it will feed it to the computer inside to drive, how to drive and how to stop, how to brake and everything, something like this. So these are all artificial intelligence. That human is not doing it, right? So a computer program is doing all these things. So artificial is a general term which we call uh, to make a decision on its own by a machine or program. Okay. The other term involved here in data science is machine learning. So this is the definition coined by Tom M. Mitchell. But generally, what a machine learning is, if you take one computer program, okay, it should learn on its own by performing some tasks. It will gain some experience. Okay, if a program performs some task, it should gain some experience. Okay, based on an experience, if it is given new tasks, the performance should be increasing. How it is, the learning should be improving. Okay, if such improving happening, then we call that program as machine learning. Okay, we are teaching the program to learn based on its experience by performing some tasks. Okay, so this is the general term for machine learning. Okay, it is this term is closely associated with the data science, like I showed in the Venn diagram. So machine learning helps a good part in the data science. Okay, so what are the methods that involved in machine learning? rhythmically make prediction, okay, and algorithmically decipher patterns in the data. Machine learning is capable of doing these two things. Instead of hard coding or writing a hard set of rules, we are letting the machine or the computer program to learn on its own by performing some tasks with some experience. Okay, that is the general definition of machine learning. Okay, and the other part is deep learning. Okay, so this is one part of the machine learning. I mean, whenever there is a complex data is there and complex patterns are involved in the data, typically normal machine learning algorithms cannot capture what are the patterns and what are the insights in the data. Deep learning helps in finding those things. Okay, so generally we call a deep learning network as neural network. Okay, the general term coined as neural network because it mimics the neural networks of our brain. Okay, in our brain, the most information transfer happens through neurons. Okay, how each neuron connects and fires whenever something happens, right? It will learn something like this. Okay, it will be having one input layer and one output layer and numerous hidden layers. Okay, so these are all called neurons. Okay, like how our neurons work in our brain, these are also learned from the data. This is input layer is data is given to the hidden layer. Okay, so these neurons learn typical patterns that are present in the data, like how a human learn. Okay, so this is this is how deep learning works. And generally, these terms gets confusing, like what is data science, artificial intelligence, machine learning, and deep learning. So we can put something like this, okay, into one diagram if you want to learn. So anything that is not human thinking comes under artificial intelligence. Okay, so a little part of data science comes here. Okay, because some work is done by the machine. So that is why I put something like this. And machine learning. So we are teaching a program or a machine to learn on its own, right? So that is also comes under artificial intelligence. Okay, and deep learning. Deep learning is a part of machine learning where normal machine learning algorithms couldn't capture the whole data pattern. Okay, there deep learning helps us. Okay, so don't confuse like difference between all these things. So what is the other part that is not present of this artificial intelligence is this might be a domain knowledge, okay, on what all the like banking knowledge, or if you are into manufacturing, that knowledge, or automotive knowledge. Okay, this part will fall there. Okay, so currently come to this today's topic, AI in banking. Okay, so these are some surveys results, okay, that is done by Allied Market Research. Okay, so global AI in banking market is expected to reach 64.03 billion by 2030. So there is a huge potential of involving AI in banking sector. Okay, so and at a CAGR growth, okay, 32.6% within this decade. Okay, so this is a huge growth that banks nowadays are trying to implement AI into their sector. Okay, so general statistics of AI in banking. Okay, so this is one US agency's research. Okay, by Autonomous Next. So okay, this agency's research is showing so banks can able to reduce cost by 22% by 2030 using artificial intelligence. Okay, this could save them $1 trillion. Okay, so reducing costs means I mean, suppose the live example which currently we are working is a target marketing the customers. Okay, so instead of sending SMS or calls to the group, like blasting all the messages, we can target some group of people might be eligible to some campaign. Okay, I mean credit card campaign or some e-commerce campaign. So we can target people and we can send SMS to those groups only. So there is a little bit cost reduction for us in communication there. Okay, small example, but can be done in many verticals there in the bank. Okay, so the financial companies employ 60% of all professionals who have skills to create AI systems. Okay, people who has skills to create AI systems in the banking, they want to increase the employee to 60%, something like that. Okay, and the most important technology they are trying to inculcate this face recognition technology. Okay, it is to prevent a credit card fraud and all. Okay, this only gonna save them 20% in 2022. Okay, revenue growth. So this is how general statistics of artificial intelligence in banking. Okay, so what are the different applications of data science in banking? Okay, the banks are employing these methods in front office and back office both. Okay, so here I've listed out some 8. Okay, the first one is smile to pay, facial scanning to initiate transaction. If you want to initiate a transaction, you should the front camera might be opening and you should smile at the screen. So this is like one security thing to ensure you are the right person of the right account to do this particular transaction. Okay, so that is what a smile to face. And micro expression analysis on virtual loan officers. So instead of going to bank, getting appointment, spending so much time there, so it is better to have a virtual loan agent. Okay, within your mobile or within your tab, laptop, something, you can talk to a virtual agent. You can tell to him your needs. I mean, you want to take loan or to a credit card, something like that. Okay, so something like this one part. And biometric verification, like fingerprint recognition, and fraud patterns, cyber security attacks. For fraud patterns like taking a huge amount from the account in an unknown location, something like that. Okay, so fraud patterns and conversational bots. I mean, chat bots or something like that. You should talk with the to the bank using a chatbot and all. Okay, if you send your query to the chatbot, it will analyze it. If it can solve the solution, it will give back to you. Otherwise, it will escalate it to the higher authorities so that your problem is getting solved and all. Okay, and humanoid robots. Nowadays, they are deploying these humanoid robots in most of the banks in Singapore. Okay, some robot will be some robot in the entrance will be asking you to come and to interact with it. What are the service that you required in this particular branch and all. So reducing the human involvement and error rate there. Okay, and machine vision, like computer vision and the natural language processing to scan the documents to see the documents are counterfeit or it is I mean changed or something like that. And real-time transaction analysis for risk monitoring. So it will it will see all your transactions in real time. If there is any risk involved in a particular transaction, it will alert you, I mean, send an SMS or email to you to verify whether you are the person who did the transaction. So there are many verticals where we can apply data science in banking. Okay. So this is like fraud statistics in US in 2019. Okay, so there are many digital attacks that are happening in US. Okay, leading to massive data breaches and leakage of vulnerable information. So the last thing a bank is expecting is the leak of their data, their customer data. So they don't want to leak, right? Even though many cyber attacks are happening. Okay, so due to this. Fraud or cyber attacks. So in the US in 2019, 388K cases happened. Okay, it resulted in 1.9 billion of losses. So this is a huge amount to be lost by the fraud thing. So they want to employ some a good model or any artificial intelligence model to stop all these things. Okay. So to gain the customer's loyalty and safety and prevention of data theft and all. Okay. So generally the solution they are going is if we create old rule-based approach. I mean, writing rules to call it as a fraud. It is difficult. Like there should be many rules to be written to call a transaction fraud. Okay, instead of writing all the rules, prescriptive or predictive analytics on machine learning can be used. Okay, so machine learning algorithms can be able to find can smartly derive correlations. Okay, correlation between the transactions. I mean, whenever the last transaction happened, the new transaction happened, and the location of the transaction and all. So it will gather all the background information that happened in a particular transaction. Okay, and it can give a hint to the customer or the bank. So this might be a fraudulent transaction, something like that. Some signs that can give the model a hint. Okay, how to tell a good transaction, whether illegal or not. Okay, so mostly on customer behavior. One example, how he usually make purchases. If he purchases something in e-commerce, only electronic things he was purchasing. Suddenly, a transaction happened in other thing with a huge amount of money. So it might be in unusual location. This might be tracked as a fraud detection or something like that. So that is what I mean. If you want to write a hard-coded old rule-based approach, it will take so much time and cannot write all the internal patterns that might lead to a fraud transaction. So AI helps here to see the correlations and different type of combinations and history of past transactions. It will match it and it can give you a hint, something like this. So this is one big application of AI in fraudulent transactions. Okay. So how a algorithm will learn to take it as a fraud or something like that. Learning the behavior of customers. Okay, how previously they transacted, and it will analyze all the aggregated data, social graphs. I mean their age. They'll take their demographic values and their product holds and something like that. Okay, and a routine process. It will if it is a routine ATM withdrawal, it might not be any fraudulent something like that. So routine processes it will capture and withhold in the algorithm, and it will control the user ID information. So based on the ID given to a user, it will track what are his past transactions, so that it might not be a fraudulent transaction to detect as. Okay. And one more major application currently, which we are also employing in Hong Leong Bank, target marketing. This is our main thing which we are doing. So we are having 3 million customer database with Hong Leong Bank. So it is impossible to communicate with all the 3.3 million customers based on some products newly launched by the bank. Okay. So what we do is we divided something like 4 things, like mass marketing. So this is unidentified marketing. So blasting all the SMS or calls or emails to many people. Okay. And the other one is segmented marketing. So we segment people into different clusters, and we treated them with a particular product. Whenever a particular product comes to us, we will share the campaign details to particular group. Okay, niche marketing and micro marketing. So calling each individual to tell a particular campaign or a particular loan process is coming up, something like this. Okay, so mostly we are using segmented marketing. Okay, so customer segmentation. It can be done in qualitative insights and quantitative insights. Okay, mostly we are doing this one, behavior based and predictive analytics. Okay, so what behavior based will do is an approach that divides customers into groups based on their previous behavioral data, transactional data, and other data sources. Okay, we'll take all the data points involved here, and we make them grouping. Okay, how we group them is by applying a clustering algorithm like k-means clustering or hierarchical clustering. Okay, so these are some machine learning algorithms we can, or statistical algorithms which will help to cluster people based on their behavior. Okay, so what we can discover is new unknown segments in large amounts of data. Suppose if a 60 above group people are there, they are very much interested in putting their amount in FDs. Okay, those people will be segmented into one cluster. Okay, when the people who are from 20 to 35 age, they will be put into e-commerce segment. Okay, whenever any e-commerce offer comes like Flipkart or Amazon, new offer, we'll blast SMS to those particular group of segment of customers. Okay, so that they'll know that so some e-commerce offer is there, so we utilize this offer using Hong Leong Bank credit card or something like that. Okay, and predicting also. I mean, for predicting insurance takers, currently we are using the predictive analysis in motor insurance sector. Okay, people who are not part of motor insurance from Hong Leong Bank, so we are gathering the data, and we are finding some patterns in their purchases, like toll gates, fuel stations, and service stations, and auto parts. Okay, so we are not aware they have a car, but we know all the details from their transactions. From those transactions, we are predicting whether this person might be a taker of insurance or not. Okay, so there we use classification algorithms. Okay, taker or not. Okay, if he takes, what is the amount? Amount is a continuous value, so we use any regression techniques to find that value also. Okay, so and this maybe many more applications, like to predict churn rate and any particular product, will they buy or not, or something like that. Okay, so this is qualitative analysis. It can be done on very less amount of people. So just talking to them and getting the insights from each customer. So this is a small type of analysis. I mean, if you have a customer base of very few guys, you can go with the quantitative insights. Okay, sorry, qualitative insights. So this is how customer segmentation is happening currently. Okay, so we are using clustering algorithms and classification algorithms to find the right person to get marketed. Okay, so how the clustering analysis is done? Generally, we gather the data from the customers. We address any missing data is there, and we use statistical models like imputation techniques to fill the data if it is missing, and if there is any outliers are there, we use outlier techniques to fill the data, and we'll scale the data. Okay, scaling the data is one feature of age is in number, and other feature he might be gender related, male or female. So algorithm couldn't be find what is categorical variable and what is numerical variable. So at the time we scale the data, we convert them into numericals and all. Okay, this part comes under data preparation, first part. Then we do exploratory data analysis, like I showed you the process of like the data science life cycle. So this is exploratory data analysis. We explore using pair plots and all. Okay, how two features are related, like their credit card purchase and their age. Okay, and their gender, something like that. We plot some graph so that we get some insights from those, and use cluster techniques like k-means clusters and all. Okay, and we will evaluate whether the segmentation has done correctly, or how many clusters are done correctly, or something like that. There are two methods. Elbow method. This is one statistical method which help in identifying right number of clusters. Okay, so this elbow bend will give us how many customers should be taken. Okay, and silhouette coefficient will tell us how clearly there is a boundary between two groups of customers. Okay, something like that. This is a brief analysis how we do customer segmentation. Okay, and what are the uses after doing the segmentation? Okay, we can do personalized banking. Okay, so as you might aware, there is it is a different banking system from India to Malaysia. So generally we get many calls from banks calling, we have this loan or we have that loan, you are eligible for this one. Okay, something like that. But in Malaysia, their banking rules are very strict. Like, you are not supposed to contact your customer until their consent. Okay, you should able to call them within 45 days only one time, and SMS only 2 to 3 times per month, and email only one time per month, something like that. So it's very strict rules. So we should be very good in finding the right customer and sending him the right email or call or SMS. Okay, he should be part of the campaign. Okay, so for that, generally this is one example. Suppose one Anya, she's 28 years old, she's working professional. So how can we personalize her with all the data which we are having? Okay, so we can collect her data of nearby apps she use. Okay, like maybe fitness apps she's using, So we can send her any fitness related offer coming from Hong Leong Bank with any particular gym or something like that. We can send her something like this. Okay. And facial recognition for payments. Okay. No need to put card and waving and all. So just you show your face. So it can be able to do a transaction, something like that. And a personalized offer, like I said, for a gym, like one example I said, for health, if she is eligible for health campaigning, we can send her offers from the bank, so she'll be eligible for this offer, so you get some discount or something like that. Okay. And money management solutions, and we can share her spending analysis. Suppose she's doing more thing on like cabs, she's spending more on cabs, so how can she save on the travel thing? Okay, something like that. Personalized money management solutions. We can show them the analysis on her app, on the banking app. Okay. In daily activities, we can do some analysis. Today, she might have spent on food 30% amount on food, 20% on cinemas or something like that. So that analysis will help them. So where they're spending more money on which department or something like that. And savings and investment recommendations. So now we are currently doing one project on FD, fixed deposit. One number should be shared with the particular customer. How much interest rate will be given to them if they put FD with Hong Leong Bank. Okay. In India, FD rates are fixed, but there it is volatile. So based on this regression analysis, we can able to find a particular customer to give him a good FD rate, so that he can put his amount in the bank for both revenue growth for bank and him. Okay. So can be done in different verticals: intelligent banking, personalized banking, omni-channel, and banking and beyond banking. That is what beyond banking is. Definitely collaborating with nearby apps to get more insights for them. Okay. And AI first institution. Okay. So what all the things AI can be done in a bank to put it as total AI dependency and all. Okay. So in the future, bank should be get all these things: profitability, personalization to each customer at a good scale, omni-channel presence, and the speed and innovation. Okay. So what all the things can be done here is customer acquisition. Okay. And credit decision making. Suppose if any customer come to us to have a credit card or a loan, something like that, we can analyze his data and how risk it is to giving him a loan or something like that. Okay. And retention and cross selling. Suppose a particular customer is eligible for a particular campaign, we can cross sell him another credit card or another debit card or something like that, any other account for his children, any insurance account to him. This is cross-selling and upselling can be done based on their history of transactions and all. Okay. Service and engagement. Now we can serve a customer a more better if we know their feedbacks and all. Okay. That data can also be processed. Okay. And these are different capabilities that AI can be put it in the bank. NLP, natural language processing, voice scripts, agents, bots, computer vision, facial recognition, blockchain technologies, robotics, behavioral analytics. Mostly you can concentrate here in behavioral analytics so that we can do better service to the customer. Okay. And one more important application the banks are using is churn rate prediction. Churn rate is like people who can leave the bank, okay, dissatisfied with the bank, so they want to leave. So our algorithm should be able to predict those customers who are ready to leave or something like that. So what we have the data is previously churned customer history. Okay, I mean people who left the bank, the data which we have. So we should able to find a pattern in those people why they left. Okay, what are the things that are happening before they are leaving? I mean they are removing all the amount, they are subscribing, they are unsubscribing the bank's policies or newsletters or any other insurance product they are unsubscribing. Okay, we should be able to find the pattern there, and should be able to create one predictive model. Okay, and we can get two guys out of this one, two classification: customers at risk of churn and happy customers. This also we can know, okay, from this one. once we got the list of people who are at risk of churn, okay, we can do proactive re-engagement with our banking people, calling them and discussing them. So why they are unhappy and what transaction made them unhappy, something like that. What offer make them unhappy. So better engagement with them and better offers if you provide them, they better stay with the bank and all. Okay. So churn rate prediction is also important application in banking. So this is the thing which I explained here. So as to identify potential churners, machine learning algorithms can do a great job here. Okay. They reveal some shared behavior between the patterns of those customers who have already left the company, like I said, and so it will check the behavior, the algorithm, and it will give us a signal. So this particular customer might churn from the bank because his past transaction is happening in a pattern. Okay, if this pattern is detected, he might be a churn customer, something like that. Okay, something like this. And one more vertical of artificial intelligence in banking is NLP, natural language processing in banking. So main three verticals that are using now NLP are investment analysis, okay, summary insights and sentimental analysis. Okay, what is the sentiment of a customer? How he's reacting to the offers and how he's reacting to the amount that credit limit increased or something like that, sentiment analysis. And document search. Suppose if you are applying for loan or some other account open information, you are giving your documents, right? So NLP can do the KYC and the legal things issued, whether this is a counterfeit document or it is a original document, something like that. And the customer service and insights. So chatbots, every bank nowadays have a chatbot with them. So instead of directly talking to the customers, you can give your grievance to the chatbot. It will do some analysis and it will give the insights from there. Okay. So this is one NLP in the banking. So some examples of NLP use cases like intelligent document search. JP Morgan is the biggest bank. It uses one AI algorithm called COIN. Okay, contract intelligence. Okay, after introducing this chatbot and this software into JP Morgan Chase, it saved banks legal time. Okay, legal teams time, 360K hours. Okay, so that is a huge time it saved and almost 15,000 days. Okay, so if it done by manually, it will take these many days to do all the document verification and all. 15,000 days in the sense we need to employ more people to get it done with within less time, right? So instead of that, we can use one chatbot or artificial intelligence algorithm to do it automatically. Okay, so generally, what chatbots will do, it will collect 24/7 data at 365 days. Maybe banking people will be available from 9 to 5 or 10 to 6, something like that. But in the night or some holiday session, if you have any doubts or queries, you need to approach the bank. You can use the company's chatbot. So it will collect the data and it will analyze the data. So this help generally 800 million working hours total the banking sector. Okay, so this much huge impact is with chatbots in this current industry nowadays. Okay, and the topic after this one is the technologies which we are using here. So generally we are using cloud computing. Earlier we used to use traditional methods using Excel and all, but what is happening is if you use traditional method, our data, our algorithm couldn't process 150 plus transaction in a second. So we have 3.3 million customers, right? So many of them are making the transactions parallelly. Somebody is drawing from the ATM, somebody is online shopping, something like that. Okay, so using traditional method, we cannot oversee each and every transaction. Okay, so time, effort, team sizes, more it is required. Okay, so for that, what we are trying to do is we inculcated everything into cloud computing. Okay, so it has a higher scalability and many platforms we can use this part. Okay, and faster time to market, reduce time by providing managed service. I mean, if you want to set up a new environment for new algorithm, it will be very easy in doing the cloud, doing in cloud. Okay. So the next is big data. So 3.3 million data, like I'm saying, it is very huge data, huge customers, and many features will be there: their age, their gender, their transaction history, their product holding, and everything. So that data is huge. So we generally call it as a big data. Okay, simple thing. So that is why good solution is cloud computing. So normally, if you do it in our computers or in our laptops, it will be very slow process to oversee everything. Okay, so if you go for cloud computing, we have many features here. One is database and security. If your database is in cloud, and whenever any transaction happen, the data is directly stored in the cloud. Okay, here we can have TBs or petabytes of data in the cloud, and we can access the data or that virtual machine using any of our devices. Okay, even though if you are at home, you can connect to that virtual machine using your mobile or tab or something like that, and can see how data is getting stored and what data is getting stored and all. Okay, so reducing cost and overhead. So if you want to buy a good infrastructure to store everything, it will cost you a lot. Okay, compared to cloud computing. So here you can easily rent a small system and work there, something like that. And fast computation process. So if you take a good GB of RAM and good GB of CPU core from the cloud computing, and you put your data there, it will easily process the data, and it will give you insights very quick and all. Okay? Dynamically stable, scalable server. So I mean, finding the data in the server is very easy. So by storing them in buckets, it will be very easy to retrieve the data whenever you are required. Okay. So this is a good solution for big data and cloud computing. So that is what I just explained. We can compute power, we can get it from computation power and database storage, application, and other IT resources. That all can be done in the cloud computing. Okay, it is pay as you go. I mean, if you want to take one service, you pay for just for that service. Okay, not for everything. If you want to buy a good computer, it will cost you a lot. Then if you pay to use one small service from the cloud, you just pay some $100 and all. You can get that service done by easy thing. Okay, and we connect from wherever we have internet. If you have internet, you can connect to multiple devices, and you can go there and work and see how the things are going on there. Okay, instead of going to, if server is located in the office in a particular location, you have to go there, you have to see how things are going on there physically. So here you can be done everything virtually. Okay, so generally we are doing GCP, Google Cloud Platform. There are many cloud services that are there. Like AWS, Amazon Web Services, GCP, Alibaba, and Microsoft Azure and all. We taken into consideration of all these things. Okay, cost effective, highly scalable, and custom machine types, IoTs, and all. Okay, so for these some particular reasons, mostly cost effective GCP compared to AWS, and good computing power also available here. So that is why we generally chose Hong Leong Bank, the GCP. Okay. And how we are doing here our analysis in GCP is mostly using Python. As you can see, this is a small survey data from KD Nuggets till 2020. So the Python is the most used language by the data scientists. Okay, so more than 80% people who are into data science field and all, they're using Python. Okay, so these are all also required. I mean, SQL is required to bring data from the data warehouse to the GCP or to your own laptop to work on this one. So these are all required, but Python is the most used language nowadays because community support is very good, and there are many more libraries in Python for deep learning, machine learning, and all. Okay, compared to other languages, there are many libraries and technologies like AutoML kind of services are available in Python. It is very easy to code in Python and to work in Python as nowadays. So we are also employing Python in current our work. So this is customizing notebooks. Okay, notebook is one Python place where we write code in the notebook. Okay, so this is one sample picture of Google Cloud Platform where we use Python. Okay, so here we can select the environment like TensorFlow, Python, and all, and we can take a good computing power systems. Okay, with the 300 GB RAM or 1 TB RAM and 16 core CPUs. Okay, to fast compute the data which we are having. Okay, so we can customize the notebooks in the cloud. Okay, based on our requirement, based on the data, we can customize our notebooks and all. Okay, so this is generally a small example of Python, how we write a code in Jupyter notebooks in cloud platforms. Okay, so here we write the code, here we execute it, and the pipeline also created itself in the Google Cloud platform. I mean, starting from the data collection, coding, model development, and deployment of the results. Okay, everything as a pipeline, we do it in GCP. Okay, auto pipelines, many pipelines are available in GCP. So this is AI Cloud, how AI Cloud on Google. Okay, so people who are familiar with all with the Kubeflow, deep learning, and machine learning frameworks like data scientists and machine learnings can use this part of services from the Google Cloud. Okay, like if you can able to write code, you're good with all the frameworks, you can write your own. Okay, using the libraries scikit-learn, PyTorch, and all. Okay, like using algorithms, XGBoost, and all. If it is a deep image recognition techniques and all, we can use the deep learning VM images, which is a pre data set, which is already available in the data Google. We can go there and we can train our model on the available images, and test images can be provided to the algorithm, and we can find the results there. Good. Okay, so ML pipelines, like I said, end-to-end ML pipelines like data collection, model development, refresh rate, and deploying the results. Okay, everything can be done using Kubeflow. People like data scientists, ML engineers who are good with all these things can directly do on their own. But people who are not familiar with all these concepts in depth and doesn't know coding and all, like application developers, they can go with AutoML, BigML, and AI platform for training and predictions. Okay, AutoML is one newly coming technology. I mean, instead of writing the codes on your own, the platform like Google Cloud will provide you one black box algorithm called AutoML. So nothing you have to do there. Just you have to put your data into the algorithm. It will give you the predictions. Okay, no coding is involved in that. Just give the data to the black box AutoML. It will pre-process the data, and just you have to mention which algorithm is required for you. Otherwise, AutoML can only decide on itself what is the better algorithm for the predictions and all. Okay, Bigquery Ml. This also trains and save the models within the Bigquery data, and it will help you in predicting the business problem or solutions without writing a single line of code. Okay, so this is AutoML for application developers and all in Google Cloud. So this is generally a brief introduction and the concept here. So just want to go with the Q&A session. So anybody having doubts, you can feel free to ask.
So I think this was quite informative, Sathish, and possibly very detailed, like a detailed session on how you are actually implementing a lot of these solutions. Now, a few of them that I really loved is the slides where you showed AI first institution and personalized banking. That's exactly what a lot of companies are possibly following in today's world. Okay, so I think a lot of valuable insights. There are a few that I would like to clarify. Like there are some questions that I would like to possibly ask you, and I'll open it up for all the participants as well. So we'll have certain questions that you would like to get up present to you and learn from you. So I'll start with some very fundamental ones. Like let's start with the idea that you quoted that you have moved completely to cloud, and GCP is that of your preferred choice, right? Now, in this, as a company, do you prefer investing in more serverless, or do you work on creating infrastructures from scratch?
I mean, going for serverless is a quick solution as of now. I mean, it is like with the security which we are having in the cloud sector as of now, it is safe and sound to use serverless techniques with the cloud. Yes. So instead of building dependency creation, and nowadays we are all moving virtual, right? No offices and everything virtual thing. So going to cloud is a better solution as of now. That is what I'm thinking. But actually, banking sector people might afraid like data might be thefting data might happen in the cloud and all. But there are stringent laws and solutions there with the GCP or AWS, any cloud solution provide. So any like a 3 to 4 type of token authentication required to access the data. Okay. And before putting our data into the cloud, we have one more administrative person who sees everything, the data, what we are going to put in the cloud. I mean, we mask the people account number. Suppose we mask the account number with a randomly generated number, so that if theft also happen, they doesn't know which customer data is that. Okay. So simple, this is a data of X customer, something like that, they know. Okay. This is one more preventive step which we are employing right now. Yeah. Yeah.
Eventually, I mean, this question will always be there that data, is it secure or insecure on the cloud?
Yes.
How do you convince your stakeholders? Because back here in India, it's going to be a big challenge convincing customers, right? So how do you convince your customers?
Yes, we had the session with the Google guys about the security. Okay, what are their terms and how we can recover if there is a data theft or something like that, and prevention techniques like employing a person to manually see the data. I mean, what data is going on, and in which server, where that virtual server is located. I mean, this particular server it is located in Singapore. Okay. So the bank is not willing to save somewhere in US or something like that. Okay, inside the continent or something like that in Asia, they prefer. So they have some more branches in Singapore also, something like that. So we went through all the security systems with the Google. Okay, who can put the data into our storage thing? Who can access the data which is present in our storage? And what is the token authorization? I mean, how many people required to authorize the data to bring into a Jupyter notebook to work on? Okay, these are 4 to 5 security measures we imparted there. I showed them the business people, so we can prevent any data theft and all. So they convinced the technologies using by the Google to save the data and all. Yeah.
And to some extent, even if you encrypt it, you always need to decrypt it, right? So,
yes.
So again, how do you ensure that the decryption logic is not there on that server? So at some point,
I mean,
everything is residing in GCP, so anybody can look into it, right?
Yes.
So
sometimes
complicated, yeah.
Yes, it is complicated. Once the results are out, I mean, if we got the leads of a particular campaign, we pull everything into one CSV file or one Excel file. We again pull that into our local systems, okay, bank server, okay, and there we decrypt that one. Not the decryption part is not happening in the cloud. Okay, once we are good with the results and predictions with the GCP, we take out and pull out the results and we decrypt in our bank server. There we can able to match the customers. From there we will proceed. Yes, decryption and encryption part is happening in Hongliang servers, and the coding and data analytics process is happening in the cloud. Yes.
Yeah, so I think this is the point that I wanted everybody to understand. Yes. That in spite of using cloud, if you are in a highly secured environment, so if you are dealing with very sensitive information,
yes,
all said and done, you still have to maintain your own servers. You still have to maintain your own infrastructure, because not everything can be out there in cloud. You need to have control over certain things. So just like as Sathish mentioned, that most of the decryption logic and all sorts of masking of the data and everything happens at your local server. The cloud is only kind of a processing system for you. Okay, it's not the brains behind it. The brains are all stored with you. Okay, even if not the brains, at least the key should be held in your hand and you should not let that go. So this is a very good information, not only for banking people, but for people from any industry for that sake. If you're dealing with sensitive information, just make sure that you control the secrecy of the information at your side, not at the cloud side.
Cloud side, yes.
Okay, so this was very important. I think, Sathish, two very vital points. One, go for as much as serverless as possible. At least it's faster time to market. And two, it's a lot lesser hassle to manage and implement. So that's very important. And second is keep your encryption at your end, or keep the safety always should reside at your end.
Yes.
Right. So that is something that you would definitely want to aspire for.
Yes.
Now, in this regard, very specifically in GCP, if you are building machine learning solutions, can you let us know how do you plan the pipelining? How do you set the pipeline? Do you have an idea? Like, would you like to share the idea of which components of GCP do you use exactly?
Yes. So after masking the data, we put the data in the Bigquery. Okay, Bigquery, Google Bigquery. Okay. So if any like data pre-processing, anything required, we can, and still more processing of the data required, we do it in Bigquery. Okay, our bank data is stored in Teradata actually. Okay, so from Teradata we pull everything into GCP using masking and all. In GCP, if more required, we do it in Bigquery. Okay, first part is Bigquery in the pipeline. There we store the data and all the script required for the processing the data. And again, from there, a data frame is formed there using the data. The data frame is pulled into Python. Okay, there we do all the analysis and model building using the machine learning techniques like algorithms and all. Once once the results are predicted by the program, we take the CSV file to the to the deployment pod. Okay, we see what are the results predicted by the algorithm, and we decrypt the leads, and we send it to the communication department. Okay, they do the marketing on the leads which a particular customer is belonging to which campaign and all. So this is one pipeline which we are doing it. Every month we refresh it. I mean, leads will be different from one month to other month. I mean, if you suppose insurance renewal leads are there, so 1 month after January, some guys might their insurance might be completed, so they are not part of the leads for the February month. Okay, so this pipeline refreshment happen automatically in GCP. Okay, but only part is after generating the leads, we take the leads into our system and decrypt them, and we send it to the marketing team for communication purpose. Yes. Yeah. Yeah.
Great. I think this is interesting. So I'll move on to some questions that our audience is posting. Okay. So VK Dubey says how much Google AutoML costs. I think VK, it's primarily it's need basis. What are you using?
Yes.
Okay. On basis of that, the costing is. For understanding costing of cloud, what I would recommend is just go ahead and read the pricing page. You need to understand certain components, like what is the bandwidth that you're using, what services are you using, what is the network usage, what is the number of APIs that you're calling. Okay, so there's a lot of complexity on the costing bit. So they have predictors, calculators. So you can put in all the details and they'll give you the pricing. Okay, so there's no easy way to answer what is the pricing till you don't actually know what exactly you're using. Okay, it's like saying what is the price of some slipper. Okay, now which slipper you're talking about, which brand is it, what is the size of the slipper, okay, what is the color of the slipper, what are the features of the slipper. Okay, so you without all those details, you just can't price anything. Right? So likewise, in cloud also, you need to go a little detailed as to how do you price it. Can you dwell on a bit of use case hierarchical clustering versus k-means clustering in customer segmentation banking? Do you have any preference as such, Sathish, or?
Yes, I mean, yes, we are using k-means clustering mostly here. I mean, the data is mixed type here. We have categorical variables and numerical variables. Okay, so k-means and k-means prototype clustering algorithms are much more good in creating a good boundary between the clusters. I mean, not overlapping clusters or something like that. So that is why we preferred k-means and k-means prototype clustering other than the hierarchical clustering. Yes. Yes.
Okay. And specifically for the categorical data, are you doing any kind of encoding?
Yes, one hot encoding and a label encoding. Based on that, we do encoding there. Yes.
Okay, perfect.
Yes.
Okay, so Chiranjit asks, encrypt decrypt is okay for static data, but how about real-time continuous data? I think Chiranjit is the same. Even if it's a real-time data, it doesn't mean that the very second it is generated, you're using it very second. There are multiple layers. What you see on TV is actually a delayed version of what was happening in the ground. Okay, so there's nothing called as real-time. In between, you put a lot of layers. You put encryption in that transition itself, and then you send the encrypted data in a stream format itself. Okay, so there's no difference there. Coming down to the next question. Okay, this is a very interesting question. It might be a little broader. It's quite broad, but I think still it might be quite important to understand viewpoints of data scientists. So, as we keep increasing our usage of data science and AI more in banking space, right? Where do you see the future of brick and mortar bank? So banks that have physical stores, physical locations. Okay, what do you think is going to happen to those banks eventually, and those people those banks?
Okay, even though the AI is into this sector, so banking is mostly people involved with money, right? So they need trust basis first thing. Even though the services can be done mostly by AI and all, but instead of for trust basis and to get more customer interaction, walking into the branch will also help. For some guys, the new age generation, we are okay with working on the technological devices and all, but people who are higher old age, so they have some trust issues whether the bank is there or not. If they go and sit with them, they can physically talking to the a teller or someone, so they get more trust with the bank, something like that. Even though AI is coming, but people are creating new branches also in the banking nowadays, because based on the population increases, they want to get nearer to the a group of customers. New areas they are selecting where very less people are into banking or something like that. So they want to put a branch there and asking the customers to, whenever they're interested in a loan product or something like that, come to face. We can give you better solutions and all. So it is mixed. Mostly on trust basis it is going on. Yes.
Yeah, absolutely. At the end of the day, there's a very popular saying, right? Artificial intelligence cannot beat human intelligence.
Yes.
So, point is, irrespective of banks automating a lot of these things and possibly bringing a lot of AI solutions, you still need to talk to a person at times, and that's why you still will have people sitting in branches. Though a lot of the jobs inside those banks would have eroded. So something like probably a person who's just doing a matching of the records at the end of the day, that guy can be easily replaced with a automated system that does the reconciliation, right? So some of the jobs will definitely be lost. However, physical presence of banks will not be gone, because we still are humans and we prefer physical interaction, or we like interaction face to face. And at the same time, we feel more confident when we talk to a person versus we talk to a computer, right? So automation is something that you augment into your system and not replace the system, right? So it's more of an augmentation.
It will help more understanding a customer before he visits to the branch also. If you took some appointment tomorrow, I'm coming for this particular interest, we can use these techniques to understand the customer better. So we can address his point particularly, pinpointly. We can address his problem. That will help a little bit more also. Yes.
Perfect. Yes. Okay, so Pranav says, how does encryption? Pranav, it's pretty straightforward. Just read about a little bit of encryption and decryption. You'll understand the idea. It's like the name Pranav. I'll change it to Apple. Okay, so behind the scenes, I've mapped Apple to Pranav. Okay, so that's basically one very simple way of encrypting. Okay, but there are many more complicated techniques that we use. But again, just for from a layman's perspective, I can just name Pranav as Apple. And if I get information that Apple has paid 500 rupees, so that's like Pranav has paid 500 rupees. So behind in my server, I store Apple and Pranav as the mapped keys.
Yes. Similar.
It's very complicated. Can we take Google help? Because a lot of so VK Dubey, the answer is yes. Usually these cloud providers, they So I'll just give you a context, Sathish. So VK Dubey is concerned about the complexity of costing, which is, I agree to that point, that it is always a little difficult to gauge. And that's the whole reason why Google actually gives a lot of free credits at the start. Okay, and if there's a tie-up with your company, you can actually take a trial version and see how does the costing turn out. And then, because when it's a large scale one, right? You always
every individual. I mean, Google now giving $300 credits to every individual. If you have a credit card, they'll charge you $1 for 1 year. Okay, just 1 year. You can use free credits for $300, and they have many documentation of how to learn and how to use these notebooks and everything in GCP. I mean, whenever you are using it, will time basis. I mean, if you work on this notebook for 1 hour, you'll be charged some 60 cents. After that, you can stop it. And whenever you are again, you want to work, you can use it. Then charging will be started at that time. But there are good things. I mean, they are not continuously charging if you take one system for a whole 1 year or something like that. Whenever you are using, use and pay, something like that. Yes. So good start. You can have it if you have a credit card. You can register with your email, and for one rupee you can work.
Right, and in fact, it's a bigger organization, and they tie up with Google. They definitely provide a lot more credits for you to try out.
Yes.
So that's a different use case. So VK, if your company has a tie-up or does want to do a tie-up with Google, you can avail more credits to understand how the system works and do a costing also. So costing access, in fact, you can sit with the team. They can guide you what is the costing.
Sales team will help you.
So there will be a lot of support that these cloud providers are providing, because everybody wants you to take up their services, right?
Yes.
If I am running a cloud service, I'll do anything to make sure that you take my cloud service.
My client, yes.
Yeah. So this is a very good time and very good opportunity. Every cloud service is dying to get more customers. Try to extract as much as possible.
Yes.
A good time for you to do it. When is ML used versus DL used in real life example? Sukin is asking this question. So Sathish, you might want to pick up some example here. But so before you give that answer, Sukin, I'll just add one very beautiful point, which I'd read somewhere, that you don't kill a mosquito with a machine gun. Okay, so Sukin, in short, that's your answer, but I'll leave it to Sathish to answer this.
Okay, good. That is correct. I mean, a simple layman term in like answer. So I'll give you a small example. I mean, if our data is like 10,000 flight going customers we have. I mean, people who travel through flights, we have just some 10,000 guys. So we need to do a small prediction on those people, whether they might fly in the next season or not. Okay, the data is very simple, and we know their history. So usual time of travel, usually how much they travel and all. A simple machine learning logistic regression algorithm will help you in predicting that part. Okay, but if you have if given you one picture of an animal or something like that, you have to tell this is a cat, dog, or something like that. Okay, so then for that particular thing, you should be your model should be trained on a huge amount of data on huge number of pictures of different kind of animals. Okay, so there to find the patterns in a particular image, you need deep learning, that is CNN or some other algorithm which is having layers inside them, neurons inside them, to see which pixel is helping to predict that animal. Okay, so at that time you need deep learning, I mean like CNN algorithms and all. Okay. If your data is huge and there are very much complex patterns are involved there, so you better go with deep learning. Otherwise, if it is a simple normal prediction and small classification problem, you can go with a normal ML algorithms and all. And DL is also part of a machine learning, but it helps in finding the complex data patterns and all. Yes.
Yeah, absolutely. If you have worked on DL, what you'll understand is that DL is primarily used for more complicated data like unstructured data such as text or images or videos or voice, audio. Yeah. So that's why DL is primarily used. So it's not that you use it as a vice versa, but it's more like very specific needs where you use ML, where you use DL. So I think, Sathish, we are way past time. I know we have eaten up into some extra hours of here. If it's okay with you, one final question and then we'll wrap it up.
Yeah, can.
Okay. So, before I ask the final question, everybody, we are sharing a feedback link with all of you on the chat window. Plus, we'll be sharing it on our mail to all of you. please make sure you spend some time filling up the form. It'll be of great help to not only the speaker, but to us as well, because we'll know what was good, what we could have done better. So please take some time and fill up this form, and whatever is the feedback, we'll also share with Sathish for his reference. So please do fill it up. Okay, so Sathish, one quick final question. Okay, and this is always, it's a little kind of, what do I say? It's a little personal question from all the audience. Okay, so the question is, what if we want to target for jobs in Malaysia? What should we do, especially in data science and AI space?
Yes, there is a huge potential nowadays in Malaysia in AI and ML thing. So first thing is you make your profile with sample projects. Okay, so what is your, you should showcase your knowledge to the recruiter first. Okay, so that is why you put your GitHub link. I mean, if you have one or your sample projects which you have done, detailed descriptions, you add those in the resumes and all. So once if they see your resume, they should be confident that this guy has been working on these technologies, and what are the results you got from doing those projects and all. Okay, so mostly they look on project oriented only in Malaysia. I mean, what are your previous projects, what are your experience and all. Okay, but as I start, how to get noticed by the recruiters from Malaysia is use your LinkedIn profile. Okay, and monster.my Malaysia, you have a separate thing in Malaysia. Monster is very much used in Malaysia compared to in India. Okay, and JobStreet is one more good site to get noticed in Malaysia and all. Okay, and you just connect with people or HR in Malaysia through LinkedIn. Okay, grow your network by sending them messages or connection requests, with not like simply sending adding and all. You put a personal message, something like that. I have done this much in this field, I've learned, these are my skills, if any opportunity comes up with you, you share with us, something like that. Okay, a detailed description and all with you. These are the things that will help you in getting noticed for Malaysian clients. But I can say there is a huge shortage of data scientists and machine learning engineers and all in Malaysia. Yes.
Okay, I think thanks, Satish. That was pretty detailed. One quick verification on that same question. So, does Hong Leong Bank have opportunities, and if so, where do we apply it?
Yes, we have some 2 or 3 positions open up as of now. You can go to LinkedIn site of Hong Leong Bank. Okay, then you can find there in the careers or jobs section. You might get the link where to apply there. Yes.
Perfect. I think thanks for that information. So, though a little shamelessly kind of promoting our candidates here, but definitely there are a lot of qualified people who would want to kind of avail opportunities in Malaysia, just like you, Sathish. So, on a parting note, the last thing that, or the last guidance bit of tip that you want to share with everybody, the mic is all yours.
Yes. Okay. I mean, the main challenges which I faced and which I learned from people who are coming into data science and AI, don't concentrate much on the libraries. I mean, the technology and all. Learn in detail of statistics or probability or math behind the thing why we are using it. Okay, and try to get your hands dirty on the real-time data where you can get on Kaggle or somewhere. Do an end-to-end project on your own. I mean, from start to end, you do the data processing, you do the algorithm development. If you do something like that, you will get to know what are the difficulties if you face if a real-time data is given to you. Okay, something like that. And one more thing is, don't get lost in this huge information about different sites and different getting more information from YouTube and all. Okay, so it is every time it is good to get information, but confined to one particular topic to one particular person. Okay, if you completely understand one topic, then only go to the other topic. Okay, not juggle one topic in between different sources. That is the thing where you get lost most of the time. Yes, so that is 1-2 suggestions from my side. Yeah.
Awesome. I think this is something that we often keep telling our students as well, that with the information overload that is going on around, a lot of people miss out the most basic stuff, which is what have you done? Have you got your hands dirty? Have you done one simple end-to-end project? Okay, have you learned the nitty-gritties of how do you solve a certain business problem? So till you don't get your hands dirty, there's no use of talking about jargons and 10 other things. And I've watched this YouTube video, watched that YouTube video, and I've read this research paper. And this is a mistake a lot of people actually do. But good that Sathish, you actually made it quite obvious to everybody that all said and done in the industry, nobody cares about how many articles and theses you have read. Everybody is interested. Have you done one step, which is have you implemented something from end to end? That's it.
Yes. That's right.
Yes, that's wonderful insight, Sathish.
Yes.
So, Sathish, first of all, sorry for the delay. I think we took up a little bit of extra time of yours.
It's okay, no problem.
But we thank you wholeheartedly for the wonderful information you shared. I really love those slides where you actually discussed about how these applications are being done at a personal level. I mean, that's something that very few people actually are able to understand and comprehend. But the way you explained it, that was very, very layman, very easy to understand. And that personalized banking slide itself got me kind of really excited, like, oh, this is like awesome, right? So thanks a lot for that, Sathish. Really happy. I on behalf of the entire community, I thank you for your time. And guys, feel free to thank Sathish, and please feel free to connect with Sathish as well. You'll get to learn a lot.
Yes, you can connect to my LinkedIn, like I shared in the site, Punati Sathish. You can connect me there. I'm happy to help all the time. And thanks for this opportunity for the Insaid. Yeah.
I mean, it's totally our pleasure. So thanks a lot, Sathish. Take care. Have a great day.
You too.
See you.
Everybody.
Bye. You may all terminate your sessions now. We are done for today. Thank you all. And please make sure next week we continue the journey with some more fantastic speakers from Southeast Asia. There's a lot to learn and a lot to do. Thank you all. See you.
Thank you. Thank you. Bye.